Hello, welcome to Zigmatech Learning Hub. I will be your instructor for further mathematics. For this class, we are going to be taking our exercises from the ExamGuide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, GCE, KCPE, IJMB, JUPEB, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. You're welcome to today's class once again. Our topic is matrices, part 3. Specific objective at the end of this lesson, you are expected to define linear transformation, explain types of linear transformation, solve problems on the types of linear transformations. Linear transformation, as the name implies, linear, is just a matrix or one mapping of a point called the object in a plane into a point called the what? The image. What are talking about matrix? Matrix multiplied by object equals image. So linear transformation of matrix is what? One mapping of a point called the object in a plane into a point called the what? The image. For every formation of image, there must be a product of what? The matrix and object given. Types of linear transformation. We have the rotation, reflection, and enlargement. For the sake of the level you are operating, we are going to limit our learning to what? Rotation and reflection. But majorly, what you are expected to know is the what? The rotation under further mass. Now rotation. Talking about rotation, when you rotate an object, it changes its position. Rotation could be 90-degree anticlockwise moment. It could be 180-degree anticlockwise moment. It could be what? 270-degree anticlockwise moment. Let us take a look at when the rotation is just within 90-degree anticlockwise moment. Your cardinal point, that is the vertical axis and the horizontal axis, which we know to be y minus y, x minus x. Rotation, 90-degree anticlockwise moment. Rotation, 90-degree anticlockwise. Simply means you are moving from here. This is your 90 to left. This point. Meaning the object x, y will produce an image. Let us look at the nature of the image. The image, the starting point is y, meaning y is here, while the ending point is what? X. But following the direction and rules of x and y axis, x is supposed to come before y. But because of the nature of the movement, y is coming before x. So the only thing you are to do to acknowledge that the position of x is supposed to be here is to transfer the sign of x, which is minus, transfer that minus to y, while the sign of y, which is plus, transfer it to what? X. Meaning the formula now, which is called the image, is what? Minus y and x. While the object is what? X, y. This is formula for what? Rotation, 90-degree anti-clockwise moment. Thinking about 270-degree, this same point, you move from here, 180-degree. This is 180, you move this way. Meaning object equals image or implies image. Just use equals image. What's the image? Starting point is minus x, ending point is minus y. We don't have any problem with this. The formula stands the same way because x is the starting point and s should be the first point to be counted when we are considering the horizontal axis and the vertical axis in a plane. For 270-degree, this is 180-degree, like I said, anti-clockwise. Now 270-degree anti-clockwise, object equals image. That is our image. Move from here to here. Starting point is y, ending point is x. But by right, the first letter or variable that should have come is what? X. But because of the nature of movement, y is now taking the position of who? X. Therefore, accord x is respect with the sign is carrying, meaning plus. That is, y is going to be plus instead of minus y. Then x will now take the sign of y to accord a respect, telling y you are supposed to be in this position, but because of the nature of movement, I am taking your position. Therefore, let me accord you the respect by taking the sign that belongs to you. So, this is the movement. Another way you can do this, you can solve by formula method. That is, I have cos theta, I have sin theta. By differentiation, if I differentiate cos theta, it will give me minus sin theta. I differentiate sin theta, it will give me cos theta. Now let us look at how this formula works. To show you, it's going to produce the same thing I am having here with the R of 180, 90, and 270. So, cos 90 is 0. Sin 90 is 1. Because sin is having minus sign, you put the minus. Sin 90 is 1, cos 90 is 0. Meaning, this is the what? The matrix. Now, matrix, like I said when I started, matrix multiplied by object equals what? Image. So the matrix of the transformation is going to result to, by virtue of the multiplication, this is a matrix, while this is object, like I called it before. Let's see if it's going to produce this image equals who? Image I. That is, by virtue of multiplication of matrix, 0 times x is 0 plus minus 1 times y. It will give us what? Minus y. That is, I have here minus y. Now 1 times x plus 0 times y equals what? X, meaning I have x here. Look out for the formula. By scale drawing method, minus y and x. By formula method, after differentiation of cos theta and sin theta, still minus y and x. Therefore, that formula stands to be true. The same thing applies to that of 180 degree. If you do, you are going to see. Let us test that one too, so that we'll now start to solve some questions based on rotation. Okay, for 180 degree, I'll say cos 180 minus sin 180 degree, sin 180 degree, cos 180 degree, cos 180 minus 1, Sine 180, sine 180, cos 180 minus 1. This is our matrix, multiplied by object x, y equals image. This time, this is minus x, you have it. Then, this time, this minus y. Can you trace back, please, the solution or the formula for 180 degrees? Can you see that? Minus s minus y. What I see here? Minus s minus y, meaning the proof confirmed that it is what? True. I don't think you have anything to complain about the formula about rotation, either 90 degree, 180 degree, 270 degree, or 360 degree, as the case may be. All you need to do in an examination hall or any exam you are writing, pay close attention to the question they are going to ask you. Now, let us take some samples. Find the vertices of the image of the triangle ABC, which undergoes a rotation of what? 90 degrees in the anticlockwise sense. If the vertices of the triangles are what? 0, 0, 1, 1, 1, 4. You have to be tactical about this thing. What are we looking for? Find the vertices of the image of the triangle, meaning matrix has existed. What is the matrix there? That 90 degree will produce our matrix. What is our object? ABC. Now, what is our image? Image is what we are looking for. Now, let us see how we can generate the image. I will use the two methods to solve. Anyone you find it is easier for you, fine. The first one, x, y equals this under 90 degree. When you move, you rotate. This is y, this is x. So the first one is s. You accord the respect for x. So it is what? Minus y and plus x. Now, what are we having? We have object. What is the object? We have object A to give us what? What's object A? 0, 0. So, A prime, which is an image, equals, so implies 0, 0. For B prime, B equals 1, 1, then B prime equals minus 1 and 1. C equals 1, 4. Then C prime equals what? Minus 4, 1. Let us use formula method to solve. This is drawing methods, or maybe the proof through rotation on the cardinal points of x and y. So using this, cos 90 degree, sine 90 degree, sine 90 degree, cos 90 degree, multiplying by our object. What is our object? We have zero, one, one. That's 0, 0, 1, 1. Then 0, 1, 4 equals to now image. So cos 90 is 0, sin 90, 1, 1, 0. Let us multiply. This is 0, 1, 1, 0, 1, 4 to give us what? Image. So what are the image for this? 0, minus 1 against 0, 0. 0 minus 1 against 1, 1. 0 minus 1 against 1, 4. Our solution here is 0, 0, okay? The next solution, which is 7 as what? A prime. The next solution, this is 0, okay. 0 times 0 plus minus 1 times 0 to give us 0. For this, 0 times 1 plus minus 1 times 1 equals minus 1. Now the next, we'll have 0 times 1 plus minus 1 times 4 equals minus 4. The next, 1, 0 against 0, 0. 1, 0 against 1, 1. This will give us 0. While this will give us 1. The final one will give us 1, 0, 1, 4 equals 1 times 0. 1 times 1 plus 0 times 4 equals 1. Now let us position to see the solution. Positioning this image, this matrix is going to be what? 2 by 3. So the first solution, 0. Second solution, minus 1. Third solution, minus 4. The next, 0, 1, and 1. So if you watch very well, here represent A prime, B prime, C prime. Watch out for the solution. What is our B prime? B prime minus 1 and 1. See it, minus 1 and 1. C prime minus 4 and 1. Minus 4 and 1. So choose the one you think is easier for you to solve. Next question. We have find the matrix P which transforms the image of the triangle with vertices A00, B32, and C1, 5 onto a triangle with vertices A prime, 00, B prime, 3 over 2 minus root 3, 3 over 2, root 3 plus 1. Okay, let's look at that question. So the question is, find the matrix P we transform, meaning they are looking for matrix. Recall that matrix M multiplied by object equals who? Image. OBJ. Object. Now, when you look at our object, we have 2 by 3. That is, matrix M into our object is 0, 0, 3, 2, 1, 5 equals what? Image onto a triangle with vertices A prime, that is image of the triangle, equals what we are seeing there. Look at what we have. That is 0, 0, 3 over 2 minus root 3 against 3 over 2 plus 3 over 2 root 3 plus 1. Again, (1 over 2 minus 5 over 2 root 3 against root 3 over 2 plus 5 over 2. What is the order of the image? 2 by 3. What is the order of the object? 2 by 3. Therefore, the order of the matrix is going to be what? 2 by 3. Let us see how it works. We must assign unknown to the matrix by saying A, B, C, D, E, F into 0, 3, 1, 0, 2, 5, then equals the image given to us 0, 3 all over 2 minus root 3, 1 all over 2 minus 5 over 2 root 3, then 0, 3 all over 2, root 3 plus 1, root 3 all over 2 plus 5 over 2 will multiply out this way. Okay. Our matrix is going to be 2 by 2, A, B, C, D. So that this multiply A times 0 plus B times 0 equals 0, equation 1. Then A times 3 plus B times 2 equals 3 over 2 minus root 3, equation 2. A times 1 plus 5 times B equals 1 over 2 minus 5 over 2 root 3, equation 3. Then, forming equation 4, C times 0 plus D times 0 equals 0, equation 4. C times 3 plus 2 times D equals 3 over 2 root 3 plus 1, equation 5. Then 1 times C plus 5 times D equals root 3 over 2 plus 5 over 2, equation 6. Now let us begin to resolve the equation one after the other so that we can get the value of A, B, C, D. Now, having seen this, I want to wipe it so that we can have space for our work. We have seen this. Now, looking at our equation 1, everything for equation 1 is what? 0, which is the first position. For equation 2, 3a plus 2b equals 3 all over 2 minus root 3. A plus 5b equals 1 all over 2 minus 5 all over 2 root 3. Considering this equation separately, we can get the value of A and B solving simultaneously. So call this guy equation 7, call this guy equation 8. Equation 7 multiplied by coefficient of A, which is 1. Equation 8 multiplied by coefficient of A, which is 3. We're going to have 3A plus 2B equals 3 all over 2 minus root 3. Then 3A plus 15B equals this is LCM of this one here, This is 3/2 root, okay, 1/2 minus 5√3. Let's get the LCM. 1/2 minus 5√3 all over 2. LCM is 2. So this is going to give us 1 minus 5√3 all over 2. Okay? So that when we multiply by 3, it will give us 3 minus 15√3 all over 2. By elimination method, this minus this cancel this minus this minus 13b equals, we now have another challenge, which is 3/2 minus √3, make it over 1. This implies 3 minus 2√3 all over 2. Okay? So that 3 minus 2√3 all over 2 minus 3 minus 15√3 all over 2. What are we going to have? We will have, this 2, 3 minus 2√3 minus 3 plus 15√3. This would not give us this minus this gone, minus 2 plus this, meaning 13. That is 13√3 all over 2. I'll cross multiply, minus 26b equals 13√3. 13 here, minus 2b equals √3. So that b, when divided through by minus 2, b will give us √3 all over minus 2. Therefore, the value of b is what? Minus √3 over 2. So b now, b equals minus √3 over 2. Solving for a, we have that a, that's 3a plus 2b equals 3 all over 2 minus √3. When we interpret, we're going to have 3a plus 2 into minus √3 all over 2 equals 3 minus 2√3 all over 2. Okay? This will take care of this. So that 3a equals 3 minus 2√3 all over 2 plus √3 all over 1. When we solve, 3a equals 3 minus 2√3 plus 2√3 all over 2. We're going to have 3a equals this guy here, gone, 3 all over 2. So that 3a multiplied by 2 will give us 3. 6a equals 3. So that a divided both sides by 6, a will give us what? 1 all over 2, comma, a equals half. Okay? Now, it is time to solve for C and D. Solving for C and D, we're going to have that this is 0, 0. That is 3c plus 2d equals 3 over 2 √3 plus 1. The next c plus 5d equals, okay, √3 plus 5 all over 2. Now, multiply this by 1, multiply this by 3. We're going to have 3c plus 2d equals 3 root 3 all over 2 plus 1 over 1 into this plus 15d equals, multiply this with 3 root 3 plus 15 all over 2. Okay. By elimination methods, after this multiplication, by elimination methods, we introduce minus. You can see this will cancel this. This minus this is minus 13d. So let us get this part, 3 root 3 all over 2 minus 2. Then minus 3 root 3 plus 15 all over 2. So what do you have? Minus 13d equals 3 root 3 minus 2 all over 2. Our LCM here is 2. Okay. 2 will carry us through here now. This is 2. Then minus 3 root 3 minus 15. Look at 3 root 3. Gone, gone. Then we'll have 15 plus 15. This minus this. Plus 2 here, sorry, plus 2. So plus 2 minus 15 is going to give us minus 13. So that D will give us minus 26. D equals minus 13. Cancel, cancel. D equals what? 1 all over 13 all over 26, which is 1 all over 2. So we have that D equals 1 all over 2. D equals 1 over 2. Solve for C. Solving for C, we have that C plus 5D equals root 3 over 2 plus 5. C plus 5 times 1 over 2 equals root 3 plus 5 over 2. C equals root 3 plus 5 over 2 minus 5 all over 2. This will give us C equals root 3 plus 5 minus 5 all over 2. What do we have now? We're going to have C equals root 3 all over 2. Then the matrix of the transformation, transformation equals, that is A, B, C, D equals A, 1 over 2, B minus root 3 over 2, C root 3 over 2, D 1 over 2. Final answer. The matrix of the transformation are 1 over 2 minus root 3 over 2, root 3 over 2, and 1 over 2. Here, determine the matrix of the linear transformation. Px this equals 3x minus 2y, comma x plus y. Using the matrix of the what transformation, find the images of the following points. Okay, I 1, comma 1. Okay, that's a simple one. It's not going to be complex as this. Let us see and work on it. We have that P dot this x, y equals 3x minus, that's 3x, x minus y, and 4y. So that P of this y equals the coefficient 3, 1 minus 1, 4 into x, y. Now, looking at this, what do you think is the matrix? This will cancel this, so that P equals to 3, 1 minus 1 and 4. This is the matrix. We have successfully formed the matrix. Now, finding the image of the following point, matrix multiplied by object equals to image. Meaning, since we have matrix, is 3, 1 minus 1, and 4 multiplied by object. What is the object of the first one? 1, 1 equals to image. So that 3 times 1 plus minus 1 times 1 equals 2. Then 1 times 1 plus 4 times 1 equals 5. Hence, image equals 2, 5. Or you can say 2, 5. I know how you want it. That's okay. So that is the image. Let's quickly think about reflection. Reflection, the formula for reflection, the image you see when you look into a mirror, that's yourself has been reflected into the mirror. So the formula here will have cos 2 theta sin 2 theta. Under reflection, we are dealing with integration. When we integrate cos theta, we'll have sin 2 theta. When we integrate sin theta, we'll have minus cos 2 theta. So whichever angle that is given to you, this is the formula you're going to use. We don't use diagram in this. So the triangle have vertices 1, 2, 3, 2, 4, 2, 4. Find the vertices of the image of the triangle. Listen to the question very well. They are looking for what? Find the image of the triangle. Meaning, matrix is there, object is there. Now, may I ask, what is the matrix? The angle there is your matrix. While ABC, they are what? The object we are looking for. Now, what is an image? Matrix multiplied by object equals what? Image. That is simple. Meaning that if angle is 45 degrees, 2 theta, that is 2 times 45 is what? 90. So cos 90. Okay? Sin 90. Sin 90 again, minus cos 90 degree, multiplied by our object. So our object, 1, 1, 3, 2, 2, 4, equals to image. So that's all. That reflection. It's just the same thing. The only difference is that we are using integration for reflection, and we're using differentiation for rotation. Now, let us interpret our final answer. Cos 90 is 0, sin 90 is 1, 1 here, then 0 here. What is going on? You can see the formula of reflection and rotation, they are not the same. So this 2, 4 equals image. Now we want to get the solution to our image. That's 0 times 1 plus 1 times 1 equals 1. 0 times 3 plus 1 times 2 equals 2. 0 times 2 plus 1 times 4 equals 4. We'll come this way. 1 times 1 plus 0 times 1 equals 1. 1 times 3 plus 0 times 2 equals 3. 1 times 2 plus 0 times 4 equals 2. So what is our image? Image equals the first one, 1, 2, 4, 1, 3, 2. So the image is what? 1, 2, 4, 132. Let us take one more question from past question using the exam guide. You can see on the screen the question. A linear transformation is given by what? N. Let's see the linear transformation given to us. Linear transformation given by N. Sy imply 2x plus 3y comma 3s minus y. Okay. Write down the matrix N of the what? Transformation. Now you now write matrix of transformation, matrix of the transformation. If N is given to us, that is xy, this implies this 2x, 3x, 3y minus y. N into this equals 2, 3 minus 1, x, y. So that xy will cancel xy. The matrix N will be what? 2, 3 minus 1. This is the matrix of the transformation. And here comes to the end of this particular matrix. In our next class, we'll consider the other parts in matrix. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and give a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.